Today we will solve another LeetCode problem, and it's problem number 101, and it's called Symmetric Tree. And the task here is to find whether a given binary tree is symmetric or not. So what does symmetry mean here? So let's say we have this binary tree. So everything in the left subtree is just a mirror image of everything in the right subtree. So if you draw a line here from the middle, it will act like it's a mirror. So here 2 is there as the left subtree, left node of this 1. Then 2 is here in this part of the mirror also. These two are the different sides of mirror. And then left of 2 is 3. Here right of 2 is 3. Because in mirror you will see that your left hand appears right and right appears left. Similarly, right of 2 is 4 and left of 2 is 4. And when any left node is missing, then the corresponding right node should be missing. So if we had something like some node here and no node here, then in order to maintain the symmetry, there should be exactly left node with the same value. So I hope you understand. And to see a negative example of this, if you draw a mirror here, you see that till here it's fine, 2, 2. But right of 2 is 3, so we need a left of 2 with exact same value. So this violates the property of symmetry. So how can we solve this problem? So first, if root is null, then obviously we can return true because there is no such tree. If there is only one node, then also it's correct, because if we divide it with a mirror, then here it's null, here also it's null. So this is also valid. And if it has more number of nodes, then what we will do, first we need to check the left of root, the value of the node in the left of root is same as the right of root. Once that is satisfied, we can check that if this tree is the mirror of this tree or not. So we have a function, let's say, is mirror, and we can pass two trees T1 and T2. It will check whether T1 is mirror image of T2 or not. So what is the condition? The value of T1 should be same as value of T2. So this is the first level of check, that their values should be same. If the value itself is not same, then it's violated at the root level itself. Once this is satisfied, we will go ahead and compare that whatever is in the left subtree of this node, there may be more tree hanging out there, it's the mirror of whatever is in the right subtree of this. So same function we can call recursively, T1 dot left and T2 dot right and is mirror T1 dot right and T2 dot left. And if it's true for every subtree below all the nodes, so from bottom it will start returning true, and this will propagate till root. So anywhere if it's violated, we will return false. So let's see how we will write code for this. So this is the problem. It's explaining the exact same thing. And here we have a function is symmetric, which is taking as input the root node. So first, the base case, if root node is nil, then we will return true. Else, we need to create a function, let's say is mirror or R mirror, because there are two tree nodes, T1 So we just need to check if the left subtree of this root and right subtree of this root are mirror images of each other or not. And we are done. So root left and root right. And this can be null also. So we need to handle that in our mirror. So if both are null, then it's fine. If one of them is null and the other is not null, then they are not mirror images because they don't even maintain the structural property. So if any one of them are null, so if not T1 or not T2, then the only way it can be true is that both are null. So T1 equal to T2. This we can return. So automatically, if only one of them is null, then this condition will be false. Now, if this condition does not hold true, that is none of them is null, then we need to check if the values they are holding are same or not. So here we are calling for 2 and 2. So if T1 val is not equal to T2 val, then return false. So straight away it will return. If let's say here it was 5, then we would compare 2 is not same as 5, so return false. But if they are true, they are same, the values are same, then we need to process compare the same function on the left of 2 and right of 2 and right of 2 and left of 2. So we have to just return our mirror T1 left. We will compare T1's left with T2's right, and our mirror T1 right and T2 left. So let's run it for our basic case. And it says that it's true. Let's make some changes here. Let's take this case or make one of the nodes null. So it should break the constraint and this should not be now symmetric. Let's try for just one node. So it seems to work. You can try with more test cases, and once satisfied, you can submit it. So let's do that. So it says that it's faster than 49.24%. So let's try again. And this time our numbers have improved dramatically to 84%. These numbers fluctuate a bit, so don't worry too much about that. You should focus on your algorithm. If it doesn't give good number after many trials, then there is a problem in your algorithm. Now it gives 100%, both in terms of time and space. So we are on a right track.